Hello.
Oh,
How's it going?
pretty good.
Good, good. It's been a while. Okay. Okay, three of you guys.
I
Hey. All right. Have you guys been keeping up with your econ?
I had my last week with my recitation teacher.
Uh-huh.
We did a review.
Nice. And did everything come back? Do you remember everything?
Yeah,
Good.
I remember everything, but I forgot something,
Of
so
course.
it helped me refresh.
Yeah.
I didn't have my recitation because I was in no Wi-Fi zone. So,
Uh-oh.
but I'm gonna still do it. Like I'm gonna redo it.
Okay, good, 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 good.
I hope we're well with my memory.
All right, so let's see. We're on producer theory again. Okay, and I know it's been a while since we met, so let's do a quick little review. Okay, so we're talking about firms and how they decide how much to produce. And I'm sorry to say, it all boils down to dollars and cents. Okay, companies are only doing it for money, money, money. They're not in it for fun. They're not in it to help people out. Okay, they're in it for the profit. And who remembers how we measure economic profit?
Price times quantity.
Good, which is total revenue. And then
Total revenue, yes. Minus total cost.
good. Okay. So the total revenue, like you said, it's the P times the Q. So that's fairly easy to calculate, especially if we understand that idea of elasticity. Okay. And then the total cost, we started talking about it. Oops. We started talking about it last time. Okay. There's different costs we have to think about, the fixed cost and the variable cost. Okay. One thing I want you to remember is in economics, for total cost, we include all those explicit costs, but we also include all of those implicit costs as well. Okay, so explicit costs are the costs you pay money for like rent, for workers, for raw materials, for
Taxes,
electricity. Okay, uh-huh. But what are the
tax,
implicit costs?
The
The
opportunity
opportunity
cost.
cost.
Good. Okay, the opportunity costs. So this is not something that you pay money for. But whatever you do in econ, you have to think about what else you could be doing. You always have to think about what you're giving up on. Okay, so in econ, for our calculation of profit, we're going to be including that idea of opportunity cost. So if your economic profit is ever greater than zero, okay, that means you're earning more than your opportunity cost. Holy crap, that's fantastic. That means you're earning more here doing what you're doing than you could be at your next best alternative. Okay? So your decision should always be stay where you're at and keep on doing more of it. If your economic profit is ever less than zero, what that means is you're earning less than your opportunity cost. It could
But
be
could
that
it
you're
also
Mhm,
be that, let's say, you're earning more than your opportunity cost, but your cost, the explicit cost,
mhm.
are are like the amount that makes you earn less than your profit. That your profit is less than zero.
Okay, so if your economic profit is ever negative, okay, that means that you're not even earning back your opportunity cost. It could be the case that your accounting profit is positive. It could mean that you're earning some money here, but you're not earning as much as you could be somewhere else. Or it could be that you're not even earning accounting profit. Man, that's a horrible situation. That means you're losing out a lot of money. And on top of that, you're still losing out on your opportunity cost. Okay? So whenever your economic profit is less than zero, you should stop what you're doing. Stop what you're doing and move over to your next best alternative, because that's always going to be a better decision for you. And we come across that weird situation where your economic profit is exactly equal to zero. Is that good or bad? It's tough to
both.
say. Yeah, it's both good and bad. It's so. Okay, you're not doing bad. Okay, you're not losing money. You're just earning just your opportunity cost. That means you're earning the same amount here that you could be earning somewhere else. Okay, so what that means is there's no reason for you to change your mind and go do something else. You're completely satisfied. Not extremely happy, you're extremely satisfied. Okay, so For a company, they would always want to be here. They would always want to be earning positive economic profit. For the economy, for society, we would actually love it if companies were here. If companies were just earning back their opportunity cost. What that means is everybody in our economy is just earning what they should be earning. Okay, we're not being mean to these guys. We're not saying that you shouldn't be earning anything. They're still earning accounting profit. And again, if your opportunity costs are very, very high, which they should be, we always want your opportunity cost to be high. Okay, then what that means is you're probably earning tons and tons of accounting profit. Okay, it just means that you can't be earning anywhere, or you can't be earning any more anywhere else. So you are where you're supposed to be at. Okay, fantastic. Then what we did is we started talking about how to measure all of your different product curves. This is where we started getting into the distinction between short run and long run. Short run is where labor is variable. How do I write that? Let's just say labor is variable. But what about your capital? Which means what?
If it's variable, it means it's like changeable.
Yeah.
Or like...
Yeah. So in the short run, you could hire or fire as many workers as you want very, very quickly. But what about your...
The capital is fixed.
Yeah. Because, I mean, I do agree with you. You can build a new factory if you wanted to. But can you do it right now, right now, right now? No. So in the short run, the capital is going to be fixed, even though the labor is variable. So in the short run, just always think about it as you're stuck in a situation. For these companies, they only have a certain amount of capital, and all they could do is try to figure out what's the best amount of labor to add to that capital.
But Mr. James,
yes.
I talked with my reputation, and she told me like, it is variable. The labor is variable, but if you sign a contract, you can't like fire or add. So that's why you can't change it.
So if we think about it in those terms, okay, then in that situation, the labor would be fixed. Okay, so there's always different ways of thinking about this. Okay, if you say that you signed a rental contract, okay, and that rental contract is, I don't know, 5 years or 10 years, that means during those 5 or 10 years, you're stuck with it. Okay, and your labor is going to be variable. Even though you might have a labor contract, it's probably a lot shorter term than your capital contract, than your rental contract.
I have a question for so the capital will always be fixed.
No.
And almost always, or not?
So the way we usually think about it, the easiest way to think about it is your capital will be fixed in the short run. Your labor will be variable.
In the short run, yes.
But
the labor will be variable.
Yeah, okay, but that's usually the way we like to think about it. It doesn't have to be that way. Be careful on the AP exam. They might trick you up and say that labor is fixed, but capital is variable. Okay, but all we know in the short run is at least one of our resources is going to be fixed. It's usually going to be capital, but it could be something like labor. It could be something like, I don't know, if I'm an ice cream store, it might be the case that my milk, the amount of milk I have is fixed. Maybe I have a certain amount of milk that came in this month and I can't do anything more with it. I can't add it. I can't throw it away. I just have 300 gallons of milk. Well, that's going to be my fixed resource. So the basic idea of short run is it's not anything specific like your capital is going to be fixed or your labor is going to be fixed. The idea of short run is at least one of your resources, I don't know what it is, but it's going to be fixed. Okay, so the idea of short run is for whatever reason, your company is kind of stuck in a situation. Whereas in the long run, you're not stuck. You could do whatever the crap you want because your labor, your capital, everything, all of your resources are going to be variable. But that's only possible in a long, long, long time period. In a short time period, you're stuck with what you have. Okay? Good. So the first thing we did is we talked about your total product of labor, your marginal product of labor, your average product of labor curves. The reason for that is, for this example, we're assuming that your capital is fixed in the short run. So there's nothing that you could do about your capital. So what we need to do is try to figure out how many labor to hire. So what we're going to do is we're going to take a look at your total product, your marginal product, and your average product. of labor, which we're doing here. So just to good. Okay, let's just do it the easiest way first. Okay, remember, whenever you see a chart like this, you need to be able to go everywhere. From marginal, you have to figure out total. From average, you have to figure out marginal. From total, you need to figure out marginal and average. You need to be able to go every single way. Okay, let's start with this first. With 0 workers, you have 0 production. That's always going to be the case. With 0 amounts of your variable resource, you're going to have 0 output. Okay. But as you start to hire more and more workers, your output, well, at first it's going to start to rise. At first it's going to rise very quickly, and then it's going to rise a little bit slower, and then it's going to reach some sort of tip top, and then it's going to start to decrease. The way we see that is with marginal analysis. We take a look at MPL. And who remembers, not even remembers, but who could figure out the equation for MPL?
You just see how much is one in the other. So
the change of total product of labor over the change of labor.
Good.
Yeah.
The extra production you get from one additional worker. Marginal. Whenever you think of marginal, just always remember there has to be some sort of triangle there, because we do have to look at a change. Okay. So first of all, with 0 workers, marginal is never defined. Okay. But for that first worker, we had an additional 5 hot dogs being produced. But with that second worker, we had an additional 10 hot dogs, and then an additional 15 hot dogs. Why is the case that the third worker makes more than the second? That the second worker makes more than the first?
Because of specialization.
Specialization. They start splitting up the jobs. Remember, our discussion here is all based on the short run, where we have a fixed factory space or a fixed restaurant space, and let's say there's a certain number of jobs to be done. Okay, as you start hiring those first few workers, they start splitting up the work, and every single worker gets more and more effective. But then what starts happening with the fourth worker? 10 additional hot dogs, and then 5 additional hot dogs. I mean, they're still adding production, they're still helping out your company, okay? But that additional help is starting to slow down because of
overcrowding.
Yeah, it has nothing to do with the workers themselves. It's not that like they're becoming lazy or anything. Okay, it's just that you're not giving them a fair shot because you're squeezing them into this fixed capital. And there comes a point after they split up the jobs, there's no more jobs to be done. Okay, so now they're bumping into each other, they're slowing down the production. And then there comes a point where it gets very, very bad. And as you hire more and more workers, your production actually starts to go down. Okay, I mean, that's great for us to take a look at in theory. Okay, that's great for us to look at on this chart. Trust me, in real life, you wouldn't even consider these workers. You would never hire these many workers because why would you hire a worker if they bring down your production? Yeah. Okay, and then for this last one, you're just taking a look at your average product. You're looking at all of your workers all together. Okay, so that would be 5 divided by 1. That would be 15 divided by 2. That would be 30 divided by 3, 40 divided by 4. Okay, and then so on and so forth. What is 40 divided by 6? 6 point. I don't know what is that.
In the exam, they're not going to give us like those type of questions with decimals and that because we cannot use calculators, right?
I mean, you could do 40 divided by 6, I think. Okay, but I'm pretty sure they won't even give you that. Okay, they'll give you something like 45 divided by 5.
Okay.
Hopefully you guys could do that.
Yes,
you can. Okay, so for this, we'll start practicing doing math in your head, or doing some math like, what are you supposed to do? 30 divided by 7. Do you guys even remember doing this type of stuff? I don't remember.
Yes, but I did it the day before.
That's like 4 point something.
Yeah. Okay. So I'll tell you what, they probably won't give you some crazy decimals. Okay. At the most, it might be like 0.5 or something like that. Okay. But it'll be fairly easy math because econ, there's a lot of math involved, right? But the econ test is not a math test. They're not testing you whether you could do division or anything. So they just want to make sure that you understand the concept. So they're not going to make the math all too difficult.
the average product is dividing unit of labor to total product.
Total product divided by unit of labor.
Okay.
Total product divided by
And
unit
the
of labor.
marginal is the change.
Extra product from the extra labor. Good. Yeah.
Okay.
All right. And then we talked about what these product curves would look like. So if I guess I should draw top to bottom, because they are very related to each other. So here's the TPL and L. And anybody, where do I start?
On the here the zero.
In the
So,
lower, in the zero.
0. Okay, what we call the origin. Okay.
Yes.
All right. So I guess I could use different colors here. There's this part. There's this part, and then there's
Go down part.
this part of my TPL. Okay, very important because that's very much related to the different.
I have a question. The part that it goes down is like when it decreases.
Sorry, the part that it goes down is what?
Like the green part is what, like if we're doing that in the table, it's like when the marginal product increases and then decreases again.
I guess it would be red.
Es el 6 y el 7.
And then it'll be blue would be here, and then the green would be here. Good question. Okay, so at first we see that our total product is rising, but it's rising very quickly. And then we see that our total product is rising, but it's rising very slowly. And then we see that our total product is decreasing like crazy. So, showing you those points related here.
I have a question. Does this exist decreasing at an increasing rate?
One more time. Decreasing at
an increasing rate.
That's what's going on here. Decreasing at an increasing rate. If you want to see decreasing at a constant rate, it looks like this. It's a straight line.
And decreasing at a decreasing rate is when it's slowly.
Yeah, something like that.
The red one is increasing at an increasing rate, and the blue one is increasing at a decreasing rate.
Fantastic. Okay, so if we take a look at the marginals, okay, then our marginal product would be something like this. And then it would be something like this until there. Okay, and then it'll be...
It's going to be the opposite of the first one, of the total...
Absolutely not. Do not think about it that way. That's dangerous.
Why does the...
Like, I mean like the opposite, like drawing. I don't know.
Not even the opposite. They're very, very closely related, but it's not just flipping things and it'll be the opposite. Okay, so it all has to do with that idea of slope. Okay, because you guys told me the MPL is just the change in TPL over the change in L, change in this over change in that. Back to 4th grade math, that's just slope. So the MPL is just the slope of the TPL. And what you notice at first is the slope is, what's a good color? The slope is positive or negative?
Negative.
The slope is positive. It's upward sloping. And is the slope getting bigger or smaller?
Bigger.
Bigger. Okay. One way of thinking about that is, okay, so for these lines that are tangent to it, okay, you could see that it's getting steeper and steeper and steeper and steeper. That means your MPL is positive, but it's getting bigger and bigger and bigger and bigger. And then in this region, first of all, is your slope positive or negative?
Positive.
Positive. But is the slope getting bigger or is the slope getting smaller? It's positive, but it's getting smaller. Positive, but getting smaller. And at the very tip top, at this point right here, what is the slope? 0. Okay, so when your TPL is maximized is when your MPL is equal to 0. Just like when your total utility is maximized, what can you tell me about your margin utility? Is equal to 0. Okay, so for this one, you need to go back to consumer theory.
The red part of the marginal product of labor doesn't have to be touching the line.
Here?
No, the marginal graph.
Does it have to be touching the line?
Like the line of
This line?
yes or no?
Yeah, it depends. I don't know. That's a little bit more math than we need to know. It's calculus, so it shouldn't. If we're just talking about here's quantity 1, here's quantity 2, here's quantity 3.
So I start in quantity 1.
Yeah, but if we're talking about calculus, then I guess it should touch. I don't know. Okay, it's fine to leave it like this.
Okay.
Okay. All right. So in the second region, again, we see that the slope is positive, but it's decreasing. Positive, but decreasing. And then here, we see that the slope is decreasing. That means your MPL is negative. So,
Mr. James,
Mhm.
did you say you were going to do a quiz last time?
Yeah, so the homework for
When?
this week is going to be a quiz.
Oh,
Okay. But it's the same thing. You guys have all week to work on it. It's just going to be multiple choice. There's going to be no free response. Okay, but
Yeah.
the only difference is it's going to cover everything from the beginning of the class until now.
Okay, but like, so it would be quiz 1 instead of like
Homework.
quiz 7,
Yeah.
because homework would be 7.
Yeah, it'll be quiz number 1. Okay, well, and we'll only probably have like maybe 3 or 4 quizzes for micro. Okay, because there's 3 or 4 big chunks of material to cover. All right. Okay, so this is what your TPL and MPL curve looks like. On top of that, we kind of drew in what your APL curve looks like. That's this guy here. And what you see is APL rises for a little while and then it decreases. Same idea as MPL, but it's a little bit more broad. It's a little bit more spread out. Okay, because again, MPLs look at the next one, the next one, the next one, whereas averages look at everything all together. So marginals always move faster than averages. One more time, marginals always move faster than averages. Okay, but it's always going to be the marginals that influence the averages. What I mean by that is, whenever the newest one is higher than the average, then what is it going to do to the average?
raise it.
Good, it's going to raise it. Whenever the new one, the marginal, is lower than the average, then what is it going to do to the average?
Make a decrease.
Yeah, okay. So it must be the case that where these two intersect, it has to be the maximum of APL. It has to. So, I don't know, like if on a free response question, they asked you to draw the marginal product of labor and the average product of labor, and you guys were super close, and you said, oh, here's the MPL and here's the APL, you would get points off because you showed the maximum point of APL over here, when in fact it needs to be here.
Wait, talking about the homeworks, you haven't graded it yet, right?
And I'm sorry, I'm a little bit behind there. I'll get to it. I think I'm a couple of assignments behind. Forgive me. Okay. All right. So there we go with that. Now,
So the max point has to be there, like in the.
It's usually here, somewhere in the blue region.
Okay.
What I don't want you to do ever, okay, is draw the APL like here. Okay, it's not going to happen there. It's going to happen somewhere around here. Okay, just make sure that you don't draw it like this. Make sure you don't draw it like this. It has to be maximized where it intersects.
Like in the middle of the inflection point and the maximum total product of labor.
Yeah, somewhere in between there. Okay, again, it's not going to happen up here for sure. Okay, and there's no way that your average could be down here. That makes no sense. Okay, so it's going to have to be somewhere here. All right. Okay, any questions there? Because what we did from here is we started talking about, well, I mean, I understand these product curves, but what I care more about are the cost curves. Because like we said, profit is equal to total revenue minus total cost. So let's focus on the cost side. So it's the same exact story. I mean, we are talking about how many workers to hire, But on top of that, I have to worry about my fixed capital. And it's not necessarily how many workers I have to hire or how many capital I have. What matters more to my company is the cost of my workers and the cost of my capital, because that's where it all boils down to the dollars and the cents. It's not about how many people I have, it's how much money I have to pay them. So what we did was we broke down this idea of total cost into total variable cost and total fixed cost. Well, that's super easy because variable costs come from my variable resource, which usually is going to be the labor. So you could just think about the total variable cost as the total amount of money that you have to pay your workers. But that depends on how many workers you decide to hire. The total fixed cost comes from your fixed resource, which is usually going to be the capital, the rent on the building that you're using. Okay? And for that one, it doesn't vary. No matter how much you produce, no matter if I make 0 hot dogs or 1,000,000 hot dogs, the rent on my factory space will always be the same. Okay? So, we could draw this very quickly. Here's my cost, what I'll just call P, and here's my quantity of output. So for my total product of labor curves, TPL, what it was related to was the L, how many workers I hire. But now what I did is I talked about my costs in relation to how much stuff I'm producing. Not on how many workers I'm hiring, but how much stuff I'm producing. First of all, my fixed cost is super easy because it's fixed. No matter how much I produce, my fixed cost will be constant. Total fixed cost. What that shows me is if my total fixed cost is something like, let's say I have $6,000 rent. Well, what's my rent if I decide to produce one quantity? $6,000.
6,000.
What's my rent if I decide to produce 100 quantity?
6,000.
Yeah, no matter how much I decide to produce, my fixed cost will always be $6,000. That's the definition of a fixed cost. Then we talk about the variable cost. Well, that's coming from my labor. So first off, if I'm not producing any hot dogs, then how many workers am I hiring?
0.
Good. Now listen carefully. If I'm not producing any hot dogs, how many factories do I have?
1.
Still that factory, that one factory. Okay, I'm sorry to say, even if I'm not producing anything at all, I still need to pay that rent. But if I'm not producing anything at all, I sent all of my workers home. I have 0 total variable cost. But as I start to produce more and more hot dogs, what happens to the amount of workers that I hire?
It increases.
Good. And if the number of workers I hire increases, what happens to my total variable cost?
It increases.
Good. But I'm sorry to say, it's not going to increase constantly like that. It's not even going to increase predictably like this or like this. It's going to be a mix of it. A variable cost is going to increase like that.
It's going to be like that total production labor.
It's very closely related to it. Okay, I'll show you the connection soon. So that's what my total variable cost looks like. At first, it rises very slowly, and then it rises very quickly. Well, I have this guy. I have this guy. Just add them together to come up with overall total cost. Super easy.
So you
because
start in 6,000.
Yeah, and then just draw the same exact curve. That's going to be total cost, because how much is this much?
6,000.
Then how much is this much?
6,000.
Then how much is this much?
6,000.
Yeah, all you did was you shifted up your variable cost by the amount of your fixed cost to come up with total cost.
Mr. James, you know.
Okay. Going forward, drop the mister. That's weird.
Sorry.
Go ahead.
I was having trouble understanding why does it increase at a decreasing rate at first, but then the computation showed me why.
So, yeah. Nice. Did they walk you through the marginals? We'll get there today. Maybe they explain it in a different way that I'm going to explain it to you, which is fantastic. This is the reason why you have recitations. Yeah. Okay.
That you said that it increases at a decreasing rate because the first workers are very efficient, but then
Uh-huh.
they become less efficient because of overcrowding and making the total variable cost increase because they aren't efficient.
Perfect. So I hope you didn't just remember that from our discussion. What I hope is during our discussion you kind of understood what was going on, so that later on you're just able to explain it. Okay. Remember, I don't want to say don't memorize anything. I mean, you do have to remember some stuff but hopefully you guys gained the basic fundamental understanding, the logic, the common sense behind the story, and then that'll make it so much easier to reproduce all this stuff on the test. Okay. All right. Good. So those are our different total cost curves, which is fantastic. I mean, if we understand that, quick little review. If this is my demand curve, that endpoint, that endpoint, that endpoint, what's the elasticity right there?
The top left.
Unit elastic.
What's the elasticity here?
Elastic.
What's the elasticity here?
Inelastic.
Okay. Then in that case, what's the total revenue here?
Zero.
Good. What's the total revenue here?
Where?
Zero.
Zero. Good. So if total revenue is equal to 0 here and 0 here, where's my total revenue maximized?
In the unit.
Good.
In the middle.
So man, my total revenue curve, because of elasticity, is so easy to draw. Okay. Then on top of this, what I could do is I could draw my total fixed cost, my total variable cost, and my total cost. Okay. But the one I care most about, is my total cost curve, right? So I could draw my total cost curve like this. Okay, and then you guys should be able to see, starting at this point here, what do I call that?
The least you're willing to sell.
Ooh, careful. Starting at this point, if I draw a flat line, what does that represent?
That's the total fixed cost.
Good. If I take this curve and I start it down here, what do I call that?
The variable cost.
Total variable cost. Okay, but I just added them together. That's my total cost here. Okay. Somebody, what is the problem with this range of quantity? Why is that not good for my company?
The cost is the same as the revenue.
Oh, right there it is. Okay, but in this range, the total cost is higher than my total revenue is less than my total cost. So that means my profits are equal to 0. That's horrible. The reason why my profits are so low is because I'm not producing enough. I'm not even earning enough to cover my fixed cost. Imagine that you have this huge factory space, okay, but you only produce 10 hot dogs. That sucks. You're not going to be able to earn enough money to cover that factory space, to cover your fixed costs. Okay? Well, what's going on here at this point and everything to the right? What's bigger, my total revenue or my total cost? Same idea. I mean, if you think about this quantity here, Q1, what's bigger, my total revenue or my total cost? Again, it's the case that my total cost is higher than my total revenue. Okay, the reason that I'm making economic losses here is because I'm producing too much. It's great that you're producing a lot. It's great that you're earning a lot of money. But what's going on is you're producing so much that your total costs are starting to get super, super high. The reason is, again, we're talking about the short run. So you only have a certain amount of factory space. But you're producing so much that you're squeezing so many workers into that small little factory space that your costs are starting to skyrocket. Okay, so I don't want to be in this range. I'm going to be losing money. I don't want to be in this range. I'm going to be losing money. So my sweet spot is somewhere in between here and here. Because at this quantity, Q1, let's say, what's bigger, my total revenue or my total cost? My total revenue is higher than my total cost. I'm earning economic profit. But everywhere here, I'm earning economic profit. At all of these different quantities, I'm earning economic profit because my total revenue is bigger than my total cost. But remember, firms are greedy as hell. They don't care about just earning profit. They care about earning as much profit as possible. So where is my profit going to be maximized? Is it going to be maximized here?
At a unit elastic.
No. Here? No. At unit elastic? Even there, not really. Okay? We could do some crazy math to explain why that is, but it's not going to be maximized there. It's going to be maximized somewhere here. So if we're doing if we're doing profit analysis this way, total revenue minus total cost, it's really, really tough to figure out where my profit is going to be maximized because I have to start looking at distances. And I'm not sure if this is bigger or if this is bigger or if this is bigger or if this is bigger. It's really hard to figure that out. So that's why in econ we do marginal analysis. Because in econ, we don't focus on the total revenue, we don't focus on the total cost. We focus on the marginal revenue and we focus on the marginal cost. But before I explain to you how this works, what I want to do first is show you what marginal cost looks like. So we talked about all the totals. Now the next step is we talk about all the averages and the marginal. Good. So here's my total fixed, flat. Here's my total variable, starts at the origin and then starts to rise. And here's my total. All we're going to do is add total fixed and total variable. And we're going to do a little bit more math. Okay, we're going to figure out average fixed cost. Figure that out. Average fixed cost. Average fixed cost. Okay, average fixed cost is just equal to total fixed cost divided by quantity. Well, that's what average means. Average variable cost, same thing. It's just total variable cost over quantity. And then we have average total cost, which is just total cost over quantity. Of course, you could say this is total variable cost plus total fixed cost over quantity, because you know that total cost is just total variable cost and total fixed cost. The reason I did that is average total cost is just average variable cost plus average fixed cost added up together. That should make sense. If total cost is total variable cost plus total fixed cost, then average total cost is just average variable cost plus average fixed cost. I lost some of you guys right now, I'm sure, okay, because I brought in a bunch of these other variables here, okay? I know I'm throwing tons of just letters at you, AFC, AVC, ATC, TFC, TVs. It's very easy to get confused, okay, if you try to remember and memorize what each one of these guys is, okay?
The only one I didn't understand was the third one.
The average total cost?
Equals total cost over quantity.
Yeah.
And what's the other thing?
And we just know that average total cost is equal to average fixed cost plus average variable cost.
Oh, okay.
Yeah, because we know that total cost is equal to total fixed cost plus total variable cost.
What is Q?
Quantity.
Oh.
Quantity of the stuff that we're producing. Quantity of our output.
So the average fixed cost is like almost the same as calculating the average normal cost, because you do the total cost divided by the quantity of labor.
Yeah. Not the quantity of labor, the quantity of output.
The quantity of output. Okay.
So we're not talking about how many workers, we're talking about how much stuff the workers and the capital are able to produce.
And in the graph, like the averages will be the same as the average total product of labor or not? Like the...
Not exactly, but it's going to look somewhat similar.
How do they look graphed?
Oh, nice. You know what? Let's use the numbers that we had here. Okay. Oops. Okay, let's do this one first then. Let's say I'm trying to calculate average fixed cost. This one is the easiest. First of all, what's the equation for average fixed cost? Good. Total fixed cost over quantity. It's just
I don't
average.
remember them of memory. Like for the exam, we'll have to remember them.
Yeah, because you need to know these. Trust me, it's going to be super confusing for today because we're talking about it for the first time. Okay, but then you'll get to a point where we talk about this so much that you'll get used to it. Okay, but just think, we're talking about average fixed costs. And how do you ever figure out averages? You just take a look at the total and divide by how many there are. So we're looking at total fixed cost divided by the amount of quantity. So all you're doing is, for each one of these, you're taking total fixed cost divided by quantity. Total fixed cost divided by quantity. Total fixed cost divided by quantity. So that's going to be, well, it's going to be undefined first. 6 divided by 0 makes no sense. And then 6 divided by 1. 6 divided by 2. 6 divided by 3. 6 divided by 4. 6 divided by 5. What the? 6 divided by 6. And then 6 divided by 7. I never remember this one. What's 6 divided by 7? I have no idea. 6 divided by, it's a little bit less than 70. Let's say it's 63. I don't know, something like that. So you see that the average fixed cost is actually fairly easy to calculate. You just take the total fixed cost divided by how many quantity there are. And what can you tell me about this general pattern for average fixed cost?
It's 0.8
0.8.
divided by 7.
Oh, geez, man. That was way off.
0.85.
Okay. And what's the general pattern of our average fixed cost?
It decreases.
Which totally makes sense. Because all we're doing is we're taking this fixed cost of $6 and we're just dividing it by more and more quantity. Okay, we could go this further. What's 6 divided by 10? What's 6 divided by 100? What's 6 divided by, I'm making 1 million products?
It's going to be negative.
No. Gonna get close. Gonna get very, very close. Okay, but is your average fixed cost technically ever gonna reach 0?
No, it's going to get close, but not.
Good. Even if I'm producing 1 billion, 1 trillion quantity, okay, it's going to get very, very close to 0. Almost 0, but it's never going to equal 0. And is it ever going to be negative? Not really. Okay, so your total fixed cost, price and quantity, your total fixed cost would look like this. Your average fixed cost would look like this. Oops, I'm not sure why it's going up. But it would just keep on getting closer and closer and closer to 0, but never actually touching 0. Okay, so if this was 6,000, then your average fixed cost would also start at 6,000, but then it would quickly start to decrease and get closer and closer to 0. Okay.
So every time it's divided by one more.
Yeah. You're taking that same $6 or $6,000 and you're dividing it by one more, dividing by one more, dividing by one more. So it keeps on getting smaller and smaller and smaller, but it never hits 0 and it never crosses to negative. Okay. So that's one of them. And then we could do the same thing with our variable cost. Oops. We could come up with average variable cost, which is just total variable cost divided by quantity. So same, at 0 it's undefined, or actually it's not undefined. Yeah, I guess it is undefined. Then what we're going to do is we're going to do 5 divided by 1, and then we're going to do 8 divided by 2, and then we do 11 divided by 3, 3.67, okay, and then 16 divided by 4, and then 23 divided by 5, what is that going to be? 4.6, okay, and then 32 divided by 6, 5.2 over 6, 1 over 3, 5.33, and then 43 divided by 7, which is 6 I don't know, 6.15, I don't know, something like that. Okay, so what do you notice about the pattern, the general shape of average variable cost? Goes down for a while and then starts to increase. Okay, generally what we say about average variable cost is it's going to be nice and U-shaped. Okay, what we call that is an upside, or what we call that is a parabola. Okay, down and then up, down and then up. So for right now, that might not make a lot of sense why it does that. Okay, and quite honestly, the reason why average variable cost looks like that is because we drew total variable cost looking like this. Okay, if I drew you total variable cost looking like this, like a straight line, okay, then your average variable cost would actually be a straight line as well. But because I drew total variable cost like this, that's what's going to cause average variable cost to decrease for a little while and then increase.
But it's like when you graph it is like straight, well, not straight, but like a normal parabola, not like something, let's say it turns around. Or...
Mm-hmm. So if we use actual data, your average variable cost curve might look something like that. Okay, but for us in AP Micro, just think about average variable cost as a nice U-shaped parabola.
Okay.
Okay, nice and U-shaped. All right, so we got that one. And then, whoops, one last one to do. We're just going to do average total cost, ATC, which is just total cost over quantity. So
And
total
does
cost over
marginal cost have like can be graphed?
yes.
A marginal cost.
Yes, we'll do that one last. Okay, so our average total cost, first of all, 6 divided by 0 is undefined. Okay, and then 11 divided by 1, oh my god, 11, and then 14 divided by 2, which is 7, and then 17 divided by 3, which is 5.23. Okay, I don't know why I chose these numbers. 22 divided by 4, which is 5.5, and then 29 divided by 5, which is 5. What is that? 25, 5.8, and then 38 divided by 6, which is 6.2, let's say, and then I could do this one. 49 divided by 7, which is 7. All right, so what kind of pattern can we see here for the ATC? It
That I think
decreases.
like okay, I thought you were asking about like the with the graphs, because in the graph, like the fixed one is always more constant, like it stays the same always because there's not a lot to change. Well, the variable changes a lot.
Okay, so because of that, my average fixed cost is going to be constantly decreasing. Because of my TVC, the way it looks, my average variable cost is going to be nice and U-shaped. What that means is my total variable cost curve will also be nice and U-shaped as well. But what you're going to do is you're going to pick up your AVC curve and you're going to move it up and to the right a little bit. Up and to the right. It's going to look like this. So that's super messy. So what I'll do is I'll draw all of these guys over. So what I said was my average fixed cost is going to be constantly decreasing, getting closer and closer to 0, but never touching 0. I said my average variable cost is going to be nice and U-shaped. And I said my average total cost, take up that U-shape and pick it up and to the right a little bit. It's going to look something like this. The reason why I have to do that is what is ATC minus AVC?
AFC.
Good. This distance here is equal to AFC. This distance here is equal to AFC. So what must be happening to AFC? It needs to be getting smaller and smaller, right? So that means my ATC and my AVC curves need to be getting closer and closer to each other. But does my AVC ever touch my ATC? Technically, no, because average fixed cost will never exactly equal 0. It'll get very, very close, okay, but it's never going to touch.
I have to go.
I have to go as well. Okay. Good job. We did a lot of review today, and then we covered some new material. We'll finish this off tomorrow.
Thank you.
Okay. Bye.
Thank you.
Bye. Thank you.
Bye.